Hello, everyone. So this video here is a second example on substitution. I potentially have done it with you already in class. I make this video because I don't think I'll have time to cover this one with all my section. I think for substitution, I'm gonna have only time for one example for some sections. So if it's the case of your section, then keep on watching, but just make sure that I haven't already done this example with you. So in terms of substitution, if you recall, what we want to do is substitute for t. Looking at this example, it's not obvious that this is a substitution problem because we have a square here, but this is a cosine. So that's an issue. To be able to substitute, we need to have either sine or cos, not both in the same example. So we need to figure out a way to have either two cosines or two sines. There is one identity whenever you have a square that is really, really, really useful. You should probably know this one by heart. And that's a Pythagorean identity. So if you go in the sheet where I have the list of identities, there's one that's called, there's three of them are called the Pythagorean identities, but the main one is sine squared of x plus cos squared of x is equal to 1. Therefore, by this rule, it means that we can isolate sine of x in it and get that sine squared of x is equal to one minus cos squared. This is not working. Of cos squared of x. All right. So because of that, I'm just going to substitute. So we're going to have 2 times 1 minus cos squared of x is equal to 3 cos x. And that's something that's already much better. So before I substitute, I'm just going to put everything on one side. Since I have a negative in front of the cos, maybe I'm going to put everything on this side. So if I do that, I get 0 equals to 2 cos squared because there's the 2 that's going to get distributed here. So we get 2 cos squared of x and then plus, or rather minus, no, plus 3 cos of x, 3 cos x. And then finally, there's the 2 here. That's going to go on the side as well. So that's going to be minus 2. Yes. So now that we have that, we're ready for substitution. So I'm going to let t equals to cos of x. And remember here, we have to write what the possible values of t are. Since cosine always goes from -1 to 1, so does t. So -1 is going to be the smallest value t can possibly be. And 1 is going to be the greatest. So keeping this in mind, for when we solve using the discriminant, we're going to get here 2t squared plus 3t minus 2. When you do the discriminant, you're going to get 2 valid solutions. So the first one should be t is equal to minus 2. By valid, I mean that these are values for t, but the issue here for the t is equal to 2 is that we can't be equal to 2 because of this. So therefore, this first answer here doesn't lead to any solution for this equation. Second one does though. So let's substitute back and get cos of x is equal to 1/2. We're just left with drawing our wonderful circle. So 1/2 is the first value for cosine. Remember, cos is on the x-axis, so it's this line here that I'm going to extend, and I have 2 more points for special angles. So this big angle right here is going to be my 60-degree or pi over 3. I'm going to use radians. So this first angle is pi over 3 plus 2 pi n, or 2k pi. And then I have a second angle down here. If you recall, I told you in the fourth quadrant, we're going to use negative angles just because it's simpler. So this is going to be minus pi over 3 plus 2 pi n. And these here are the 2 answers that will work for this equation.